Good evening from NOAA's National Weather Service, New York Forecast Office. This is Dave Riddell on behalf of the Tropical team presenting for you tonight. We apologize for not being able to be live and in person with you, but wanted to share a bit about Tropical Storm Isaias and impacts to our area. We want to thank Western Connecticut State University's Meteorology Program and Weather Center and the New York City Long Island chapter of the American Meteorological Society for the opportunity to present to you tonight. For our overview of Tropical Storm Isaias, we'll break it up into three sections: the before, the during, and the impacts after Tropical Storm Isaias came through the area on August 4th, 2020. So let's start by going through some of our office's pre-Isaias messaging and pre-event activities beginning on July 30th and leading up to the actual event through August 4th. Isaias started out as potential tropical cyclone number 9 on Tuesday, July 28th, located at about 14 north and 54 west. A potential tropical cyclone is the National Hurricane Center's wording to describe a disturbance that meteorologically is not yet a tropical cyclone, but which poses a threat of bringing tropical storm or hurricane conditions to land areas within 48 hours. Potential tropical cyclone number 9 was expected to strengthen into a tropical storm by Tuesday afternoon and head towards the Florida coast, as you can see in the upper left. By 11 a.m. Thursday, the 30th, Isaias had strengthened into a tropical storm, and forecasts were now taking it east of Florida and up the east coast towards our area, as you can see in the lower right. At about this time, with a cone of uncertainty touching our area, New York City and Long Island to be exact, our office began to increase the messaging of a potential event, and support for our pre-event decision support started first with social media and then maturing to full-blown briefing packages on the possible forecast hazards and potential impacts ramping up to the event. Shown here are tweets from our office Twitter account on the evening of July 30th and also on August 1st, noting that we also had severe weather event both those evenings. Formal briefings to our core partners and the public started on Friday and continued through the weekend and into the next week. In addition, with another slight risk of severe weather again on August 1st, which was not related to Isaias, the importance of targeted messaging for multiple hazards for Isaias versus other hazardous weather was certainly apparent. We began to further amplify the messaging for Isaias by the weekend and into Monday, August 3rd. Tropical storm watches and warnings were issued for much of the area on Sunday, August 2nd, and the entire area was upgraded to a tropical storm warning by Monday, August 3rd. A coastal flood watch for the south-facing shores and a flash flood watch was also issued across the interior. At this point in time, given the likely track of Isaias, we were expecting the heaviest rainfall to occur across the interior with the strongest winds to the east, along with the potential for coastal flooding, especially if the surge from Isaias coincided with the times of high. Now here's Nelson Vaz, our warning coordination meteorologist, to talk a little bit more about office operations during Tropical Storm Isaias.
Yeah, thanks for the overview, Dave. Very nicely done. And I'm Dave's colleague, Nelson Vaz, Warning Coordination Meteorologist at the National Weather Service, New York. I just want to talk a little more about the weather support we provide to our emergency management, public safety partners, as Dave was talking about, even our media partners. And it's formally known as Impact Decision Support Services, IDSS. Basically, it's weather support, and the goal of the support is to connect our forecast to the partner and decision making and ultimately public actions they take to save lives, property. So, in terms of the forecasts, I think some of the best forecasts in the world is always striving to improve, and that's been aided by improvements in the models, improved radar, satellite technology, more observational technology. Always kind of striving for more cutting-edge research and more innovative research. So all this is coming together to provide some of the best forecasts. You take a look at just tropical forecasts, 48-hour forecasts, track forecasts today are as accurate as 24-hour forecasts were 10 years ago. So. Definitely kind of a given that the forecasts are improving and they will continue to incrementally improve. But as good a forecast as is, if nobody can understand it or act upon it, it's really useless. And that's where connecting these forecasts to the partner decision making, I think, is really what we're trying to do with IDSS. So it's for us. It's a year-round process. It's kind of knowing our partners, building those relationships, learning about the partner vulnerabilities and concerns, their decision timelines, thresholds, all this. I think is really key. I mean, and we're also providing that education outreach on, what does the outlook look like? What are the key products and services? What are some of the hazards and impacts that our partners should be thinking about? So all this combined, I think, lays the foundation for really, the effective weather support, and helps us provide actionable information. As I said on the top here, right information, right format, right time. I think that's what's key for our partners, able to uh, make the best decisions, and um, being able to protect, based on that, being able to protect life and property of you and us and the public at large. I think that's really kind of what we're trying to do. And here's some examples here, the different kind of levels of weather support we do provide. And the kind of at the lowest, kind of the base level, and this is kind of available, and this is kind of available to everybody, is what we provide on our web pages, more than, and our social media, some of the specialized pages we have, more than just a text product watch warning. Even though those have been improved to have, kind of more clear information, what, where, when, impact information, some uncertainty information. But I think it goes even more in depth in some of the web pages we have. Look at for a tropics example, is we have our tropical weather page, where you can get really great information on hurricane outlook, tropical outlook information, hurricane threat impact graphics, where it's kind of taking in account the most likely forecast with some of the probabilistic forecast information for different threats: storm surge, heavy rain, wind, tornado, etc., and really provides a kind of a graphical visualization of areas and time frames of concern. So a lot of cool stuff like that that's available, to the public. Graphical weather outlooks, all that stuff. The next level, kind of increasing the urgency, and where we provide, even more specialized support, especially to our public safety and media partners, utility partners, is the email. We have web briefings where we synthesize all this information that's in a lot of different spots, a lot of different, things for maybe hazards and impacts for our partners to kind of, to follow and to be able to act on, is to put it all in kind of one spot, clear and concise package, really keying in on the key hazard and impact information. And even more proactively, we'll have webinars where we're actively, upping the urgency and providing this key impact and hazard information to all our emergency management partners. And then, kind of the highest level of decision support is really the one-to-one, when a partner may have they have questions because they need to make evacuation decisions, resource allocation, staffing, that type of stuff, and we can provide that weather support they need, giving them information on, what is the most likely, threat, impact in terms of storm surge or winds. What are some of the things that possible alternate scenarios? When will we have more information? That type of thing, and I think that really helps them make the most educated decisions in terms of evacuations and public safety. So all this stuff together, I think, ultimately, it's this partnership and support is pursuing our mission of life and property protection, which is the dual mission, or a same parallel mission of our public safety partners. And it's working with the entire weather enterprise, really, to build a weather-ready nation that's ready, resilient, and responsive to hazardous weather and water events, similar to Isaias. All right, and just to kind of finish up on it in terms of the forecast and IDSS support, kind of leading up to the event, just to kind of touch on who it's being done by. This is all done with staff of 22 people, 17 of which are meteorologists, and then we have 5 great administrative and tech support staff. But tremendous amount of workload in terms of the forecast, the watch warning, and the IDSS that we've been talking about, and not to mention in kind of the restrictions of a COVID, the COVID pandemic. So really, it's an all hands on deck approach. Being safe in this environment, but it's thanks to the work of our passionate forecasters who are really dedicated to the Weather Service mission. And then in this slide, you can kind of just see this is a sample of, some of the enhanced staffing profile and kind of duties that we have. But everything that's going on is in terms of the tropical forecast operations, coordination with the different, the Hurricane Center, Weather Prediction Center, Storm Prediction Center. We're coordinating with our regional headquarters as well, surrounding offices, making sure everything's being considered, all the forecasts consistent, coordinated, collaborated. We're doing upper air balloon launches. We normally do one every 12 hours. Now we're doing one every 6 hours to help get more upper air information into the models and to the hurricane forecasters so we can improve the forecast. And as I was showing, all the continuous decision support going on all the way from 5 days out. The email webinars, PowerPoint briefings, email briefings, the webinars, conference call, consults, all that. We have the social media, phone calls, all that going on, 5 days ahead. And then the day of the event, it's shifting more to kind of near-term forecast and morning operations, we're putting out tornado warnings, special weather statements, all the data collection, dissemination of information, and still you're doing weather support during the event and then even after the event. We're talking about, again, it's it's a small staff but very dedicated, and a lot of different things going on at the same time. But ultimately, that's that's part of our how we think we can best serve and complete our mission is through this coordinated approach and all these different moving parts. But I think the end product is making sure that the public's able to be ready, responsive, and resilient to any type of extreme weather. Just to go into a little more detail, just to kind of give you an example of what our IDSS or our schedule was for conference calls, consults, the webinars we were doing. You can see here. This is you can see on the left here on Friday. Kind of four or five calls, but New York City Port Authority, New Jersey State, our briefing that we're doing, our webinar briefing to all our emergency management partners, New York City on there a couple times. But at this point, and this is where we started to ramp up 5 days in advance, is trying to get that information out. Partners have to make a lot of decisions, and 5 days out there, really kind of early planning, but where we're talking about the potential in terms of the different hazards, whether it be wind, rainfall, storm surge, marine. So all those different hazards and potential impacts, and can't get into too much detail at that time, but kind of early planning stages and when we can provide them more information. But then it continues to ramp up through the weekend, and then you can see here on August 3rd, the amount of briefings we have going. And really take one or even two people at times to provide these provide these briefings kind of on a continuous basis. We have part of the forecast staff who's coordinating with the Hurricane Center and the Storm Prediction Center, the Weather Prediction Center, in terms of taking that big picture and then doing our own analysis and downscaling the forecast hazard impact for our area. And then we have one or two people who are taking that forecast information and then connecting it with our partners and allowing them to make the best decisions. And you can see on Monday, basically a briefing every hour. Some of these briefings could be 15 minutes, some of them could be 20, 30, 40 minutes. So a continuous process, and you can see how the partner list grows, and at the same time we're getting into more detail as we're getting closer. We can provide more detail on the storm surge, the rainfall threat, the wind threat, and really what to key in on. What is the the level of concern on each. So a lot of good information. What is the confidence factors? All these things that help them make the best decisions. And you can see, starting at 5 o'clock, 5 in the morning through 8 p.m. All the calls from, you'll see New York City on there a lot of times. They have a lot of responsibility, a lot of people, a lot of moving parts, so they need a lot of information to make their decision. But you got New York State OEM, DOT, working with the Mount Holly office and Boston office to serve Connecticut and New Jersey. We have the Coast Guard, Port Authority. Again, we're doing our briefing to get everybody on the line and one consistent, consolidated message. But yeah, a tremendous amount going on. But I think that whole collaborative, coordinated effort really helps to get the information out in the right way and make it actionable and allowing the public to be protected. Just diving in. Here's an example of one of our PowerPoint briefings. And really, it's a combination of what we try to provide. And it's a lot of information here. You can see situation overviews and hazard tables. We have actually, so these are just part of the briefing slides on here. Looking at the wind threat in terms of wind speed probabilities and potential impacts, the rainfall, again, hazards, impacts, timing, uncertainty, storm surge, and then the severe thunderstorm tornado potential. These are some of the core slides. There's a few other slides in there. Really what we try to do is you're providing both an executive level briefing, kind of a high level. So these are good, these situational overviews that are, kind of the top level, like in terms of just kind of having that big level situational awareness. And these are great also slides to put up on a EOC situational awareness display to kind of have them have a sense in kind of one consolidated area. What are all the hazard impacts of concern? But then we do have them provide more granular detail in terms of the wind threat, the rainfall threat, the storm surge threat, the thunderstorm threat. So all that. I think that helps to provide that next level of actionable information, for those decision makers and public safety officials to make those, more those key kind of evacuation decisions, logistical decisions, all that. This is some of the increased specificity of detail they're looking for. So overall, the goal with this is to kind of try and serve a lot of different partners. From regional to local, public safety to media, and all of them with different appetites and comprehension of the hazard and impact information.
Okay, let's next shift to the day of the event as Tropical Storm Isaias approaches the region on Tuesday, August 4th. First, let's summarize Isaias' track through the Caribbean and up the East Coast with the following 8-day chart. Note the blue shading represents tropical storm force winds, yellow, stronger tropical storm force winds, greater than 58 miles an hour, and red, hurricane force winds. You can see that Isaias attained hurricane strength twice during its journey, but swept through the northeast as a strong tropical storm. You may be wondering why the track of Isaias shifted from the northwest to the north to the northeast, closely paralleling the east coast of the U.S. This can be easily seen by the steering current in the mid-levels and the long wave trough centered over the Ohio Valley, moving east with time. Isaias would get caught along the eastern periphery of this trough in the south-southwestern flow, which resulted in a curve and eventual northern movement. Here's the view from GO 16 True Color as Isaias trudges through the northeast. Note the clear area along the eastern portions in the right front quadrant of the storm, where much of the convection that spawned a few tornadoes across our area were generated. Here's some forecast and model guidance performance for Isaias 5 to 6 days out, shown here. The track forecasts from the global models and their respective ensembles were pretty good for this event overall. Shown here is the 21-member NCEP GEFs from the 12Z cycle on 29 July. There are two distinct clusters noted, one taking Isaias across southern Florida and into the Gulf of Mexico, and the larger cluster, which is curving Isaias up the east coast. And you can actually even see a subset of that group at 144, 168 plus hours, curving Isaias out to sea as it makes its way up the coast. 12 hours later, by 0Z on July 30th, now 4 to 5 days out, the GEFS becomes even more clustered, with the majority now clustered along the east coast. For us, this increased our confidence in the area experiencing some impacts. Even if Isaias took a hard right and curved back out to the sea from the local area, we would certainly still see marine impacts. The multi-model ensemble, consisting of the Canadian, the NOGAPS, and GEFS members, for the same time, initialized at 0Z on the 30th, shows the spread with 4.5 to 5 or so days out, with the GEFS furthest east, the Canadian furthest west, and the Navy model somewhere in between. So again, for us this far out, it increased our confidence that the forecast area would more likely experience impacts from Isaias. The 0Z July 30th model cycle, most of the models had Isaias solidly in the tropical storm intensity, as you can see in the gray shaded area in the graphic. A few of the hurricane models, such as the H-WRF and the H-MON, actually intensified Isaias to a low-end Cat 1 or even up into the low end of the Cat 2 category. You can also see that the official intensity forecast is towards the lower end of the guidance at this point, but is still solidly in the tropical storm range. Here's a summary of Isaias' journey through the eye of about 35 track forecasts from the National Hurricane Center. The uncertainty cone here that you'll see is actually showing the 5-day potential track area. All in all, a pretty good forecast. Taking a look at the National Hurricane Center's probability of tropical storm force winds greater than 34 knots issued at the afternoon of July 30th and again through August 2nd. And in the afternoon on August 2nd, you can see that the probability of the area experiencing those winds, those sustained winds, increases to over 60% by Sunday afternoon. A similar trend is noted with strong tropical force winds greater than 50 knots or 58 miles per hour as we look at the same times as the previous slide and notice that by Sunday afternoon, August the 2nd, we are looking at 20 to 30% chance of the area experiencing strong tropical storm force winds. So the trend in the probabilities continues to increase. Impacts began early on Tuesday morning, August the 4th, for the local area, as we can see here from the radar mosaic, with short fused warnings overlaid. Watching to the south of our area, as Isaias made its approach, you'll see numerous flash flood warnings in green and tornado warnings in red issued by our forecast offices south and west of us. We were watching this area very carefully, and towards the end of the loop, you'll notice the tornado warnings that we issued for Connecticut and eastern Suffolk County in association with the line of convection in the right front quadrant of Isaias. The marine buoy at New York Harbor caught the passage of Isaias with a 15 millibar drop in the pressure and wind gusts of about 70 miles an hour, with wave heights peaking at about 16 feet at the height, which you can see here in these three graphics. There's the pressure drop. There's the wave height peak there of just over 16 feet. And wind gusts in red with sustained wind peaking here on the afternoon of Tuesday, August 4th.
All right, so and looking at the coastal flooding, the hazard and threats for this area, always a challenge in our area in terms of coastal flooding, because you are looking at a lot of things that are complex geography, which is conducive to water piling up along the coast. Winds, of course, wind direction, the fetch, the speed of the winds are very important in building up that surge. Astronomical tides as well. Does that surge coincide with astronomical tides? So a lot of things we've got to look at. So for that reason, a lot of uncertainties, especially out 3 to 5 days. We're really relying on with a tropical system. Everything gets even more because of the intensity, speed, track uncertainties, and sensitivities. Everything kind of gets amped up even more in terms of little deviations in these things can have a big differences in terms of storm surge. So out 3 to 5 days, we really started looking and messaging what are our potential worst case scenarios. based again on the intensity of the storm, and at the time it was pretty consistent that looked like this is going to be a tropical storm, but also potential size and especially the track of the storm. We look at what the slosh model is, one of the storm surge models, and we look at simulations where actually something called MRMs and meows, kind of interesting names, but they're basically collections of storm surge simulations run on these slosh models, thousands of them, with different hypothetical conditions and different intensity, speed, track of the storms to give you what is the potential inundation that you could see in an area. Um, Worst case inundation that you could see in an area based on a specific storm type, and you choose the storm type that's similar to what we were expecting with Isaias. So we started out with that 3 to 5 days out. As we're getting closer in, especially I guess 2 to 3 days in, and especially as you're getting 24 hours out, where partners are really wanting to start making some decisions. That's where we start to incorporate more of the explicit tropical probabilistic storm surge guidance in collaboration with the Hurricane Center. That's now taking more into account the latest hurricane track forecast and intensity forecast, and off of those running simulations of what the potential storm surge could be. Also looking at some of the extratropical storm surge guidance, because that's really important in our area, where a lot of times, and it was the case with Isaias, you start going from a transition from a pure tropical storm to extratropical, and that combination, it's good to look at a couple of guidances, both those guidances, in making our assessment. So, based on looking at all this, we did issue coastal flood warnings for southern parts of Long Island, and also for southwestern Connecticut, or actually all southern Connecticut, Westchester coast, and also for the lower New York Harbor, Jamaica Bay. The whole reason was we saw the potential that you could be seeing maybe 2 to 4 feet of storm surge. Now the whole question is, it all depended on where exactly Isaias was going to track. Traditionally it's going to be that right side of the storm where you have that fetch and that kind of that wave train of energy coming in, as the storm's approaching, and just to the left of the center of that, just to the right of the center of that eye landfall is where you're going to have the most forcing to bring the most water in. So for that reason, you don't know exactly where that's going to set up. You have you still have about a 40-mile historically track error. Even as good as Hurricane Center's forecast tracks are, there's a 40-mile track error still historically that can occur, and that could be a big difference in terms of storm surge from one area to another. So based on this, we rely on and we message reasonable worst case scenarios. Again, the timing of that storm surge, if it comes in during low tide, less impact; during high tide, much greater impact. We had the reasonable worst case scenario, maybe seeing 2 to locally 3 feet of inundation across areas of the lower lower New York and New Jersey Harbor, Jamaica Bay, Great South Bay, Western Long Island, southern Connecticut, and Westchester coast. And then some of those open water areas, it's not only that high water, but that combination of that wave action. And overall, what we did see, and you can see some of the details we had put in the forecast, and I'll show you some of the indications, but in terms of impacts, we were kind of fortunate. The peak surge came in during low tide. That really minimized how high the water level came in, because even though you had some pretty good surge, 3 to 5 feet of surge in spots, it came in during low tide and kept water level impacts to minimal, only exceeding minor coastal flood thresholds. But you still had some pretty good wave action, so some pretty good impacts along the beachfront, and even along parts of far western Long Island Sound. We have gotten reports of pretty good damage to marinas in Westchester County, right along the coast. So next slides we'll go into a little more detail on some of the things of what exactly happened and what may have happened if things were a little bit different in terms of timing or location. Right, so here's where you can see actually what did happen, and I have a couple. I brought up a couple of hydrographs here. The one in the upper part here is for the Sandy Hook. right there on the east coast, kind of northeastern coast of New Jersey, just leading into the mouth of New York Harbor. And this other one is showing you Jamaica Bay and inward, so kind of concentrating on those two where you had some of the greatest surge that was realized and observed. So for the top one, for Sandy Hook, you can see, and that's really, it's kind of giving us an indication what is the more open water surge coming in from the ocean, and then that typically gets modulated as it goes into the tidal, estuarine areas, and also up into the harbor and up river. So we always like to look at what's coming in at the open water, and then we have some good sense of how that will get modulated. But you can see here, the blue is the actual astronomical tide forecast. So that's outside of any kind of influence from the winds, which create the surge, or wave action, or anything else. It's just that kind of that lunar cycle, and that lunar influence on our tidal action. So and then in the green here, you can see actually what happened. So you can see the tide on the morning or early afternoon of August 4th. And you can see there's a little bit of the difference between what the astronomical tide and the actually occurred. Maybe a foot or so, a little bit, more than that. But then, sorry, this is early, late morning on Tuesday. But then as you go here, as we're going into the afternoon, so this is about 16Z, which is 4 p.m., that's where you can kind of see a lot of the primary surge was kind of coming in. So we're actually going, astronomically, we're going towards low tide, but this is where the bulk of the surge was coming in. So instead of this tidal trace following that astronomical tide, you can see where all that wind forcing, that kind of wave train, because this is Isaias, well-developed storm, that all that energy coming in was actually forcing a surge that was, here you can kind of see the difference here, almost 4.25 feet difference, ahead of that, and just to the right of where Isaias made landfall. And then, once it went by, you kind of got the wind shift, and you can actually see how the surge and the water levels really quickly dropped. But then they did rebound again at the as we went into the nighttime high tide there. We were really fortunate, and that's where we did see some minor coastal flooding impacts. It was with this nighttime high tide, with kind of this rebound of the water levels. But overall, and that was probably only like 1.5 2 foot surge. Overall, we were fortunate that for, and then it's a little bit harder to see here, but some Jamaica Bay at Inwood actually had close to 5 foot surge. You have to follow this little trace here, which if you kind of just follow my arrow here, you'll kind of see that was almost, that was over 5 feet of surge. Very fortunate again that it occurred during, you can see here, low tide in the astronomical tide trace, and not during the high tide, not during one of the high tides. Here we can take a little bit closer look at, zooming in. It's a different depiction of what the surge trace and the water level trace look like at Jamaica Bay at Inwood. This is actually from our partners at Stevens Institute, who have ensemble surge model they run. But down here up here at the top, sorry, you can see in the red dotted line here, this is actually what occurred. In the purple here, you can actually see this was the forecast mean from the Stevens models on that day, and the lines here, kind of the shading, is kind of the uncertainty. But again, and then if you kind of go down at the bottom here, this is what we're actually really interested in here, is the red line here is actually the surge trace. And what the green line here is the difference between what was actually observed and what the model was forecasting. But what this really kind of depicts here, you can really see that surge that occurred during as we were going into low tide. You can see that surge was around 5 feet. Now the one thing is, and as I was mentioning, is if you move that surge, say that surge was a few hours earlier, or several hours later, and that's all dependent on the timing when Isaias came in. That would have had the potential of, instead of water levels kind of reaching, and you can kind of see it here in this red trace observed, just kind of over our minor flood thresholds. But again, that was only about a 1 foot surge. If you were talking about 4 or 5 feet, if you added 4 or 5 feet to this, you would have been wearing well into the major flood level. Now, it doesn't necessarily totally correlate that a 5 foot surge during low tide would be a 5 foot surge during high tide. But, let's say it's even 3 feet. Even a 3 foot surge would have put you into major flood levels. And when you're talking about that type of water, that's kind of starting to get comparable to the 1992 nor'easter tropical storm Irene. So really, there was potential, for some moderate to major flood impacts and significant inundation, like kind of the worst case scenarios we were illustrating of 2 to possibly 3 feet of inundation. Once you start talking about 3 feet of inundation, that's really where you start talking about life-threatening inundation. So. Just some things to think about, some of the uncertainties that are very difficult to lock down, even say 24 hours out. But we try, and that's why we really, in terms of communicating storm surge threats and hazards, we really do lean towards a reasonable worst case scenario. Just because the risk, the inherent risk with it in terms of loss of life are too great, even with a low probability event, because you have a high consequence and high vulnerability in our part of the area. And just to kind of show you if we did hit that kind of, say we had 3 to 5 foot surge during that high tide period. These are some of the potential impacts we could have seen, and we have some impact catalogs that I want to share here. We have something from December 1992, just talking about some of the impacts in that Jamaica Bay area, what you would see. And when you reached water levels, say around 11 feet above mean lower low water, which means low tide, which would have been somewhere in that range of 3 to 5 feet surge with Isaias, if you would have reached these water levels. Flooding up to 6 to 7 feet in sections of Broad Channel. Flooding, most of the roads impassable on the peninsula Rockaways, and JFK would open, but several roads leading to the airport impassable. And then, similarly with Tropical Storm Irene, which is about a foot lower than that, say around 9.7 to 10 feet above mean low water, you can see all the impacts here. And these are the type of impact catalogs we can use to communicate, and we were using to communicate what a worst case scenario would look like. And right in the middle, this is NOAA's Sea Level Rise Viewer, where again we can take those forecast water levels and show a depiction of what potentially could occur. So these are the type of information we were communicating as a potential worst case scenario, a reasonable worst case scenario. But thankfully, this did not occur. And finally, just to kind of show you, another example. This isn't a lone example in terms of Isaias, the timing of storm surge, and just the timing of it making a huge difference. This was Hurricane Gloria. Hurricane Gloria back in 1985. You can see again, the blue is the astronomical tides. The green is actually what occurred. And there was actually a 6 to 7 foot surge, but again, you see it didn't coincide with high tide. Instead, it coincided with low tide, and that was the reason. There was potential for pretty significant impacts from Hurricane Gloria along the coastal locations from storm surge, but we were fortunate again that the surge came in during low tide. So something that definitely just kind of illustrates the timing, the track, intensity of the storm is very critical, and for that reason, we do really message the reasonable worst case scenarios. It's very dangerous trying to pinpoint what's the most likely scenario or trying to get too deterministic with a forecast. So hopefully that sheds a little light in terms of the coastal flood and storm surge forecast process and what actually occurred and what could occur.
In our final segment tonight, let's take a look at some of the local impacts from Tropical Storm Isaias. A first look at the multi-radar, multi-sensor, or MRMs rainfall estimations show that most of the rain from Isaias occurred over eastern Pennsylvania and northeast New Jersey, while less than an inch of rain fell over most of Long Island and southern Connecticut. This is a small reminder that every storm is different. At the time, Isaias was moving north at around 25 to 30 miles an hour, and a dry slot formed within the storm over Long Island, which further reduced the flooding rain threat. However, it contributed to the wind and tornado threat. Here's a look at the 24-hour maximum wind gusts associated with Isaias. Widespread tropical force storms winds were recorded throughout the forecast area, particularly for Nassau and Suffolk County, where hurricane force gusts were recorded right along the coast and likely occurred within interior portions of the island. Most of our high wind events, in other words, greater than 58-mile-an-hour gusts, are from the west, northwest, or northeast, so certain trees can become hard to these types of prevailing winds and stress conditions. When we have these relatively infrequent southeast high wind events, they have been observed to be more impactful, at least partially due to introducing a stressor to the trees that have not been hardened and make it even possibly more susceptible. This would be especially true for this time of the year, late August, early to late August, when trees have their full canopy in an increased surface area exposed to the wind stress. Here's a summary of the Tropical Storm Isaias storm reports from the northeast. You can see here with the color-coding circles and the key in the bottom right of your screen. The red dots that are signifying the tropical storm damage are a vast majority of which were large down tree branches, uprooted trees that have fallen onto power lines, and things of that nature. You notice the heavy rain up to the northwest and flash flood and tornado dots here along the southern Connecticut coast. Here are some examples of some storm damage reported as a result of Tropical Storm Isaias. Typically, these were trees that didn't appear to have deep root systems, which is common in urbanized environments. However, these trees can fall onto cars, homes, and power lines, causing significant amounts of damage, property damage to boot. 2 direct fatalities were recorded by our office, and both were related to falling trees. A total of around 2.5 million people were without power at some point locally during the storm's occurrence. And you can see the movie here on the left shows you the total customers from the Carolinas all the way up the East Coast as Isaias made its trek northeast. Even days after the storm, over 300,000 customers locally were without power, and some customers went without power for up to a week. Many issues can be noted when it comes to power outages, and among them are improper generator use with carbon monoxide poisoning, summer heat and the lack of air conditioning, store closures, and refrigeration disruption for prescription storage, for example. Though Isaias produced many rotating storm cells throughout its life cycle, only 1 tornado was confirmed of the 3 tornado warnings issued by our office. On the radar loop shown, the storm relative velocity is on the right and shows the area of inbound and outbound winds associated with the Westport, Connecticut EF1 tornado. Here's an example of MRMs, again the multi-radar, multi-sensor product, the low-level rotation tracks, which indicate the area of enhanced rotation with that cell moving onshore towards Westport. The tornado was very likely short-lived, lasting only a minute or 2 on the ground. However, in that time, it caused significant damage to a beachside 2-story home. It was rated an EF1, with estimated maximum wind speeds of 95 to 105 miles per hour, a maximum width of 25 yards, and a path length of 50 yards. Damage indicators for the EF1 determination include the roof loss, but the structure remains intact. You can also notice the loss of leaves and branches to the tops of the trees, which is typical of tornadoes on the lower end of the EF scale. Social media can be an amazing tool when it comes to storm reports. This tornado was spotted and filmed coming on shore by a private sector meteorologist, and the video proved quite useful in confirming the tornado later on. Just to reiterate and to emphasize, storm reports and spotters are crucial to the National Weather Service for verification. That's it. We appreciate your time tonight, and Nelson and I will be available after the presentations are complete to answer any questions that you might have on Tropical Storm Isaias. Or you can contact us via the information listed here on the screen. Thanks again.